Assalamu alaikum to all my dear students. How are you? I hope you all are fine. This is Ikhlas Muhyiddin and a very warm welcome to my YouTube channel. Students, today I am going to explain you a very important topic related to dynamics. It's a very short topic as well, but an important one. So the name of the topic is circular motion. So students, before explaining you what is circular motion, first we all have must know about linear motion. Okay, for example, it is a vehicle and it is on a level road and it is moving in the straight line, or you can say a straight path. It is moving with the force, with the driving force that pushes this vehicle on a level road in a straight line. So this object attains linear motion. Okay, what about circular motion? For example, uh, we have a stone, okay, and tied with a string, okay, and this is the center, okay, and it is moving in a circle. Okay, so when any object is moving in a circular path, we call this a circular path, because this stone is moving on a circular path. It can be anything. It can be a car, or it can be a stone, or it can be any object. Okay, so when it is moving in a circular path, then we call it as the object is in circular motion. So when we can define it as when any object is moving in a circular path, then the object is in circular motion. Okay, now after that, if I tied this stone with a string, okay, like this, so there must be a force that allow this stone to move in a circular path. Okay, so and there will be a constant force that is applied from the center. Okay, so the objects, when they are moving in a circular path, and how it moves, because of a constant force that is applied on the stone through this string. Okay, so when it moves in a circular path due to a constant force, and that force is acting towards the center of the circle. Okay, towards the center of the circle means sorry, center of the circle, and the direction of that force will be towards the center of the circle. So that force in particular, we call it as centripetal force. So we can write it as objects are moving in circular path due to constant force. Constant force means same force acting where it acts. Okay, so acting towards the center of the circle, the center of circle. So this particular force is called this particular force is called centripetal Centripetal force. Okay, so anything that moves in a circle, so there will be a constant force, and the movement of the object in the circular orbit or shell or circular path is due to a constant force, and the direction of that particular force will always be towards the center of the circle, and that particular force we call it as centripetal force. So there are some factors. Now talking about the factors on which centripetal force depends. Centripetal force depends. Okay, so the first is, for example, if the mass of the object increased, okay, the CF, the centripetal force, will also increased. Okay, this is very obvious that if the, for example, instead of this stone, if I take a bigger object of greater mass, so obviously if we want to move that particular big object around the circle, so we will need a greater force because of the greater mass. So the second is, if the speed of the object increased, if the speed of the object increase, then CF also increased. This is again very obvious because, for example, this the object speed increases. How or when this speed increase? When the centripetal force increases. Okay, so greater force means greater speed. So the third thing is, if the radius of the circle reduced, if the radius of the circle reduced, then CF increased. Okay, what is the radius? Means if we reduces the radius, like for example, if I have this stone and this is tied with a string and I have reduced the radius. Okay, here we have larger radius, so and in this particular diagram I have reduced the radius of the circle. So when the circle's radius reduced, so centripetal force increased. So these are the factors on which the centripetal force increased. Now, so now we will consider some examples of circular motion. So we all know that planets are orbiting around the sun. The example of a planets, okay. So the planets are orbiting around the sun due to constant gravitational force. So constant gravitational force, GF. Okay, it's not that GF. Okay, it's it's a gravitational force. It's not a girlfriend, it's a gravitational force. Okay, so the force between the planet and the sun is a constant gravitational force, and it is acting towards the sun. Okay, for example, we are talking about a planet, and it is orbiting around the sun. If it is a sun, if we take it as sun and it's a planet, that is revolving around the sun. So now what is the force between both these heavenly bodies? So it's a force which we call it as constant gravitational force. Okay, that is acting towards the sun. Okay, now when we can take an example of a satellite as well. Satellites are also orbiting around the earth. Okay, so we can take an example of a satellite as well. Satellites. Okay, so between satellite and the earth there will be also a constant gf. Okay, constant gravitational force that is acting towards the earth. Okay, and the third one is the example of electrons. Yes, so electrons are orbiting around the nucleus, and due to that constant ef means electrostatic force acting towards the nucleus of an atom. Okay, so this is all for today. As I told you before, that's a short topic, and we have completed it successfully. So I hope you all understood the concept of uh, circular motion. uh, what I have explained the factors on which centripetal force depends, or on which by which the centripetal force increased, and we have discussed some examples as well. So if you are new to my channel, so I request you to subscribe my channel, like my channel, and share it as well, and hit the bell icon as well, so that you will have my upcoming new lectures from now onwards. Assalamu alaikum wa rahmatullah.